Okay, welcome to example number 1, a two-slit interference or double-slit interference experiment. Let's write down our given here on the side here. We have a number of items that we need to state. We have the slits are 0.2 millimeters apart, so that's D. D is 0.2 millimeters apart. We have the distance from the screen is listed as R, but this is really L in our notation. L is 1 meter. We have a bright fringe, the third order bright fringe, so I'm going to write that as x sub 4 is 9.49 millimeters. And we're asked to find in A part the wavelength. And B part, we're asked to find how far apart would the slits have to be for the fourth minimum dark band to occur at 9.49 millimeters. So we want to know what D primed would be for this scenario. So let's go ahead and start solving for lambda. And so we're going to assume that we have a small angle theta. So that way we can use the following equation. X sub m equals m lambda L over D. So we're going to now replace in our m. Order is 3, or is it 4? Oh, it's looks like it's 3, not 4 as I listed over here. And we can start substituting in and solving. Actually, we're solving for lambda, so let's go rewrite this equation as lambda equals x sub 3 times d divided by m times L. So lambda would be equal to 9.49 times 10 to the power negative 3 meters. The distance between the two slits is 0.2 millimeters, so that's 0.2 times 10 to the power negative 3 meters. And we're dividing by the m equals 3, that's the order number, times the distance between the slits in the screen is 1 meter. So go ahead and put that in your calculator, and you'll get lambda equals 6.33 times 10 to the power negative 7 meters. And if you were to put that into nanometers, 1 nanometer is 1 times 10 to the power negative 9 meters, and that would give you 633 nanometers. So that's part A. And now part B asks for what would D have to be if we wanted to have a dark fringe at that distance, and the fourth order dark fringe. So let's recall the destructive interference would be m plus a half lambda L all over D. And we're solving for D, so that's D equals m plus a half lambda L divided by x sub m. Okay, so for the fourth order dark fringe would be, this would be m equals 1, m equals 2, m equals 3, and we want the fourth order fringe, which is basically we have also m equals, actually let me repeat that, that's m equals 0, then 1, then 2, and then 3. So the fourth order fringe would be m equals 0, or not 0, sorry, 3. So we're going to plug in 3 plus a half times our wavelength, 633 or 6.33 times 10 to the power negative 7 meters, times L, which is 1, and divide by our distance of 9.49 times 10 to the power of negative 3 meters. And that will give you 2.33 times 10 to the power negative 4 meters, which comes out to be 0.233 millimeters. And that's it for example number 1.